actually. It's like the protect the roof. I can fetch Roger and get him to walk along the corridor there and into. So I can't go to the office until there he is. She has a nice face here. They're in here. They're in here.
Yes, enough.
That's enough, Roger. Okay. Just wait for the word action, if you would.
Okay.
Somebody else coming. All right, come through.
Okay, action. Yeah, action. Action. Action.
So, I guess we need to sort out how we take the computing. There's a lot of issues to do with analysis that I think will need to be resolved, and it's true when a lot of people see that there's something they can really use, we will learn a lot. But we need to work out how we're going to move the required data locally to where the people need it when they need it. It can't always be there, and we've got to give them tools.
Definitely, we're going to start discussing this afternoon in half an hour's time, actually, and then we have to start testing these tools. Well, first assembling and then testing these tools. Most of them actually exist, and they need deployment, they need support, they need understanding of further requirements and what people want to do with them, or what people need to do with them, rather, in order to be able to analyze the data in the most efficient way. And when I say efficient, I mean in a way that is fast and effective without wasting time, without wasting resources especially. We know we are short of resources, so for the collaboration to work efficiently, we have to provide them tools that work efficiently for them.
Absolutely. By the way, with resources, we have considerable updates on that. One of the things that was missing when we did the big review of what we needed at the beginning of this year, we missed out the heavy ions processing, you'll remember. So I've actually tried to include the resource requirements for that very different mode of running, where we don't bang protons together but ions. And it turns out not to be such a dramatic effect as we initially feared, that this actually fits into the existing resources here at CERN, and the load out there in the regional centres, for a couple of regional centres, will be appreciable but presumably manageable.
Yeah, well, this is good news in the moment we are trying to make a summary of the resources that we can have available, and then we have to adapt our computing model and what we want to do and what we can do to the resources that will actually be there. Mm-hmm. Now, I know that we are within 15–20% of our needs, so I think at this point in time we shouldn't be too much scared of a shortage of resources. Our estimates are not that precise yet. They will get more and more precise as time goes by, of course.
Yes. Because the other big issue that we will address today is this issue of how we share the resources between the different groups within the collaboration and allow the different regions to be able to give more access to their own local people while still providing services for the whole of the collaboration. And I think there's an awful lot of work that needs to be done in this sort of virtual organisation management, that the techniques and the tools are starting to appear, but they're not integrated into all of our thinking and into all of the other tools that we use. And that's going to be a major task, I think, for the next year.
Well, that's perfect.
That's what it's about. We have to prove that this isn't just pigs flying, that we can make something real.
Switch on the side.
Yep.
Careful.
This can't be reality.
You better tell it all, because it's for continuity. It wasn't flapping when we were filming it.
And
Just talk, Roger, if you would.
He always pretends that he's listening.
Of course. And I always listen with the back of my mind.
Say something about Rome, Roger, if you would.
Yes. So we're going to learn an awful lot, I think, or I hope that we will learn a lot from the physics workshop in 2 weeks at Rome. Ian has circulated a rather nice questionnaire to actually ask people what they've been using for the workshop. I know a lot of that is about our own internal software, but I think it's the only way that we're going to learn what the real requirements for analysis are going to be in 2007, 2008, to get people involved in this kind of an exercise.
Yeah, sure. On the other hand, this is the first time that we really get the feedback from a large community. So,
Do a couple of very quick questions.
sure.
When we're
Good. Yep.
okay, Dario, you have a big meeting this week. What is your biggest challenge?
Well, the biggest challenge is trying to bring about 200 people to work together in a coherent way on the same project, and make them produce something which is useful to the rest of the collaboration, which consists of the order of 2,000 people. So this group is supposed to provide tools for people for physicists in the collaboration to do their analysis, and there are several dozens of different types of analysis that can be done with the Atlas data as soon as the experiment starts, of course.
So what is a particular challenge? What is a particular point? For example, from this morning.
Well, the point is try to get the software in a state when it is usable in an easy way, that's understandable. It can be modified by almost anyone in the collaboration to suit their needs, or any group. And you don't need to be an expert in computer science to be able to run an analysis of Atlas data. That's the challenge. If the software becomes invisible, that would be the success of this project.
Okay, just a quick couple of words with Roger. The other way around.
I guess I look to you.
Yeah. Okay, Roger, what is your role in the grid project, Atlas Grid project?
Well, I've got two roles really. In the central view, then I concern myself mainly with the worldwide computing and trying to organize the resources from all the different countries in the 6 continents that are involved, try to agree common policies, make sure that all of the computing power we need is in place, all of the disk storage. And I also look at the model by which we can handle this vast amount of data with the available computing resources. And if the computing resources are not as much as we would expect, how we can trim that and still get the physics out at the end of the day.
And what's your current challenge, if you like?
My biggest current challenge is to get people. Oh, sorry, I have to think about that.
Yeah, sure,
Can I take 1 second? Actually, the way I started that one, I told you there were 2 things, and I only gave you 1.
Give me the second.
Okay, the second is just within the UK. I actually organised the computing for the UK computing project for Atlas, and that takes quite a bit of my time as well. You probably didn't need that. Okay, I think the largest challenge at the moment is simply taking the very good work that's been done so far, which has set up a prototype system, and turning it into a system that can really be used by the non-expert user, and then gaining the experience of what's going to be needed in 2007 when we really face the challenges of the data, and engaging that very large community. It's only when things work reasonably well that the non-expert user is prepared to go through the pain of actually learning to use a new system.
What is the scale of the data that you're going to need? I mean, in 2007 you're going to have a vast amount of data going out. Have you got any yardsticks for that?
Yes, in 2007, 2008, the experiment is going to be generating about 10 petabytes of data. That's a huge amount of data. If you were to store it on ordinary CDs, it would be a stack that's some 17 kilometers high. Now obviously you wouldn't use that sort of storage medium, but one of the big issues we have at the moment is what is the optimal way of handling that amount of data? What technologies are the best ones? Because you can store large volumes, but you need ready access to it so people can find those Higgses. And we need to identify very quickly what's needed to store that data in a way that can be used.
That's perfect. That was the answer I was after.
Well, we should put